play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're going to be doing co-working today. Co-working global thermonuclear war. Let's go. All right, so we're going to be doing some co-working today. We're going to be doing some hanging out. We're going to be learning about C programming. But if you prefer to work on your own stuff, that is perfectly fine because I'm going to be working on my own stuff. So what are we going to be doing today? So we're going to be working on this course over here. It's a free course on C programming, and if you've ever wanted to learn C programming, then I highly recommend this course. It is free, it is very in-depth, and you get to do a lot of hands-on C learning and programming with their in-app compiler, so it's going to be a lot of fun. So how long are we going to be doing this? So we're going to be setting a time limit for about 2 hours, and we might go for another hour after that. We will see how it all goes. So we're doing 120 minutes, and so S Master, nice to see you here, and no worries. I understand it is quite early/late where you are, and I appreciate everybody who's in chat. All right, so what are we going to be learning about today? So we're going to be learning about C Essentials Part 1, Module 3. In this module, we're going to be talking about execution conditions, so else branches, so if-else. We're going to be talking about integer and float types, conversions, typecasting and its operators, and the different loops inside of C programming. So while loops, do loops, and for loops. Controlling loop execution with break and continue, and logical and bitwise operators. Lots of fun. All right, so let's go ahead and get started. And it looks like I need to log in again. Let's do that. And I guess while we do this, I might as well put on my soundtrack so that we've got a little bit of background music in the background. Let's see, where is it? It's over here. Control logic, yeah, I mean, we want to get better. Ooh, that's a bit loud. Let's turn down the music a bit. Okay, and the audio, it's a bit soft. I'll make it a little bit louder. Okay, so if you ever find that the music is too loud or too soft, let me know and I'll try to adjust the volume. And did we log in? Could not verify your request. I guess we're going to have to relog. We're going to have to reload the page, log in. Okay, and then resume the course. All right, the conditional statement, more conditional than before. So we concluded our last discussion on conditional statements with the promise that we would introduce a more complex and flexible form soon. We started our tale with a simple phrase that read, "If the weather is good, we will go for a walk." Note that there is not a word about what will happen if it rains cats and dogs. We only know that we certainly won't go outdoors, but what we would do instead isn't mentioned. We might want to plan something in case of bad weather too. We can say, for example, if the weather is good, we will go for a walk, otherwise we will go to a theater. This sentence makes our plans more resistant to the whims of fate. We know what we'll do if the conditions are met, and we know what we'll do if not everything goes our way. In other words, we have a plan B. Luckily, the C language allows us to express alternative plans. We do this with the second, slightly more complex form of the conditional statement. Here it is. So if true or false condition, perform if condition true, else perform if condition false. So thus we have a new word, else, that this is a keyword. It is reserved. A statement which begins with else and tells us what to do if the condition specified for the if is not met. So if else execution goes as follows. If the condition is true, its value is not equal to 0. The perform if condition true is executed and the conditional statement comes to an end. If the condition is false, its value is equal to 0, and perform if condition false, the perform if condition false is executed and the conditional statement comes to an end. Okay, so either way, it's going to execute one or the other. By using this form of the conditional statement, we describe our plans as follows. If the weather is good, go for a walk. Else, go to a theater, then have lunch. So, as well as other simplified forms of this instruction, like the ones we've already encountered, both if and else may contain only one statement. If you're going to write more than one instruction, you have to use a block, as in the example below. If the weather is good, then go for a walk, have fun. Else, go to a theater, enjoy the movie. Then, have lunch. So keep in mind that if there's more than one instruction, we have to include it in these code blocks. So the code blocks are indicated by these curly braces over here. So C is one of those curly brace languages, unlike Python, which is a indentation language. SysOS says go to the store, get there 2 bread. If they bring milk, bring 12. If they have milk, bring 12. Get there 2 bread. If they have milk, bring 12? Now let's discuss 2 special cases of the conditional statement. First, consider the surprising case when the instruction placed after the if is another if. Listen to what we have planned for this Sunday. If the weather is fine, we'll go for a walk. If we find a nice restaurant, we'll have lunch there. Otherwise, we'll eat a sandwich. If the weather is poor, we'll go to the theater. If there are no tickets, we'll go shopping in the nearest mall. Terribly complicated, right? Let's write the same in the C language. Consider the code below carefully. How much bread do you bring if the store has milk? If they have milk, is it supposed to be 12? So if the weather is good, if nice restaurant found, have lunch, else eat a sandwich. Okay, else, if tickets available, go to a theater, else go shopping. Okay, so we've got if statements inside of other if statements. So 2 important points. Such a use of the if statement is known as nesting. Remember that every else refers to the closest former if, which did not match any other else. You need to know this to determine how the ifs and the elses pair up. Consider how the indentation improves readability and emphasizes the nesting of inner conditional statements. So the second special case slightly resembles nesting, but there aren't many more similarities. Again, we'll change our plans and express them as follows. If the weather is fine, we'll go for a walk. Otherwise, if we get tickets, we'll go to the theater. Otherwise, if there are free tables at the restaurant, we'll go for lunch. If everything fails, we'll return home and play chess. Did you notice how many different alternatives there are? Let's write the same scenario in the C language. If the weather is good, go for a walk. Else if tickets available, go to a theater. Else if table available, go for a lunch. Else play chess at home. This way of assembling subsequent if statements is called a cascade. Notice how the indentation improves the readability of the code. Now let our minds work out all that we've told them about conditional statements while we pay attention to our old friends, types. Integer, character, and float. We're going to meet their siblings. Okay? My switch hands are twitching. Alright, next section. So we got some code. Okay, let's see. So conditions and conditional statements with the else statement. Fixing errors in a program, printing on screen. So check the program in the editor, find all possible compilation errors and logic errors. Fix them and try to find proper conditions for all 3 statements. Your version of the program must print the same result as the expected output. Before you use the compiler, try to find errors only by natural, not manual code analysis. Expected output. First condition is true, second condition is false, third condition is true. Okay, so let's go ahead and check for some syntax errors. So int a equals 10, if a is equal to 9, so this is part of our if statement, puts first condition is true, else puts first condition is false. If a is not equal to 9, puts second condition is true, else puts second condition is false. If a is equal to 9 plus 1, so equals equals, if A equals equals 9 plus 1, which means 10, puts third condition is true, else puts third condition is false. Return 0. So I think this code should work. Let's go ahead and run it and see what happens. Okay, first condition is false. First condition is false, but it should be true. Second condition is false. And third condition is true. Okay, so I think I know what's going on here. So what we want to do is we want to put, for the first if statement, A is not equal to 9, and then if A is equal to 9, like this. So just flip these around. Or maybe we're supposed to be using some greater than and less than. If, because we want the first condition to be true. So if A is greater than 9, then puts first condition is true. So if A is equal to 9, this has to be false, so this should be less than 9. Okay, and then A is equal to 9 plus 1. Let's go ahead and run this. We will reset. First condition is false. What's going on here? Oh, no, I got that mixed up. Sorry, I got my greater than and less than symbols mixed up there. Okay. Okay, true, false, true, true, false, true. Okay, so this is what we want. All right, we'll move on. Okay, not only the int is an int. Okay, so int means integer in this case. It would seem that the developer's life would be organized well enough if they only had type int to operate with integers, type char to manipulate characters, and type float for floating point calculations. However, this practice has shown that such a narrow repertoire of types may raise some problems. Most of the computers currently in use store int using 32 bits, so 4 bytes. This means we can operate the ints within the range of negative, how many? So this is 100,000s, this is millions, so this is 2 billion something, negative 2 billion something to positive 2 billion something. It may happen that we don't need such big values. If we count sheep, it's unlikely that we need to count 2 billion of them, so why waste the majority of these 32 bits if we don't need them? We might also need much larger values. For example, we intend to calculate the exact number of humans living on Earth. In this case, we need more than 32 bits to represent that number. This brings us to another observation after all. The number of inhabitants on Earth will never be a negative number. It seems like a real waste that up to half of the permissible range will never be used. Okay, so for these reasons, the C language provides some methods for defining precisely how we intend to store large or small numbers. This allows the compiler to allocate memory, either smaller than usual, for example 16 bits instead of 32, or larger than usual, for example 64 bits instead of 32. We can also declare that we guarantee that the value stored in the variable will be non-negative. In this case, the width of the variable's range does not change, but is shifted towards positive numbers. That means instead of the range of negative 2 billion to positive 2 billion, we get the range from 0 to 4 billion. Okay, to specify our memory requirements, we can use some additional keywords called modifiers. So the first one is long. So this is used to declare that we need a wider range of int than the standard one. Short is used to determine that we need a narrower range of int than the standard one. And unsigned is used to specify that a variable is needed only for non-negative integers. So unsigned means that the integer is not going to take a sign, it's always going to be positive. Or at least that's what I think it's supposed to mean. Although it may be surprising, we can use this modifier type modifier together with the type character. We'll explain how soon. Note that some compilers may not be able to distinguish data of type int and long. They may be synonyms. If you want to force the compiler to use actual long representation for a specific number, you can use the long type. Let's look at some examples. Example 1. The counter variable will use fewer bits than the standard int. For example, it could be 16 bits long. In this case, the range of the variable will be suppressed to the range of negative, what is this number? 32,000. Negative 32,000 to positive 32,000. So short int counter means that we're creating a variable of the int type, integer type, and it's also short, which means it fits in a 16-bit memory block instead of 32. The word int may be omitted, as all declarations are considered to be specifying int by default like this. So short is always int, is always an integer, which means that we can specify short, and that'll automatically be filled in as a short integer called counter. Example 2. The ants variable will occupy more bits than the standard int, for example 64 bits. So it can be used to store numbers from a range of negative, is that 9 billion? What is this? So this is thousands, this is hundred thousands, this is millions, this is billions, this is trillions. What is after trillions? Quadrillions? Quadrillions, and then what is after trillions and quadrillions? Let me look that up really fast. What comes after trillions and quadrillions? Is it septillions or quintillions? Okay. So after a quadrillion is a quintillion and a sextillion and a septillion. Those are some really big numbers. Okay, can you read such huge numbers? So long int ants. So long means it takes up 64 bits, I think. And then if you do 2 in a row, it's 128 bits. So an 128-bit integer, that seems like a really big integer. Again, we can omit the word int, so we do long ants, which means it's a really big integer. Or it could be. For example, example number 3. If we come to the conclusion that the variable will never be negative, we can also use the unsigned modifier. So unsigned int positive, and of course we can omit the int as usual, so unsigned positive. So unsigned implies integer. We can also mix some modifiers together, take a look. So unsigned long int huge number. We can remove the word int and the declaration will preserve its meaning. Unsigned long huge number. A more modest example is here. Unsigned short int lambs. And its equivalent form is unsigned short lambs. So this is going to be a 16-bit integer indicated by short, and it's also not going to be signed, so it's neither going to be negative nor positive. Well, it's always going to be positive. Okay, I think we can move on. So the long and short modifiers must not be used in conjunction with the type character. Why? And, for obvious reasons, must not be used simultaneously in a single declaration. But there's nothing preventing us from using the unsigned modifier with the variable of the type character. What do we get from this declaration? Don't forget that we're not allowed to omit the word character. Most of the compilers currently in use assume that the characters are stored using 8 bits, so 1 byte. That may be enough to store a small value such as the number of months or even the day of the month. If we treat the character variable as a signed integer number, its range would be -128 to 127. If we don't need any signed value, as in the example below, its range shifts between 0 and 255. This may be sufficient for many applications and may also result in significant savings in memory usage. So unsigned character little counter. But we need to add an important remark. So far we've used integer literals, assuming that all of them are of the type integer. This is generally the case, but there are some cases where the compiler recognizes literals of type long. This will happen if a literal value goes beyond the acceptable range of the type integer, the letter L or lowercase l is appended to the literal, as in 0L or 1981L. Both of these literals are of the type long. So if you append the word L to any number, then it becomes a literal. Another float type. This short modifier cannot be used alongside float, but we may use the long modifier here. It's assumed that type long float is a synonym for another type named double. The variables of type double may differ from the variables of type float, not only in range but also in accuracy. What does this mean? So Master says any literal, not any number. Any number just would be a literal. I guess we'll figure it out when we get to the examples. Okay, so what does this mean? The data stored in a floating point variable has finite precision. In other words, only a certain number of digits are precisely stored in the variable. So for example, we expect the value, so a bunch of ones, and then a dot, and then a point, and then a bunch of other ones, will be stored by a specific type of computer as 11111. Oh, what happened to this? What happened with this corruption over here? Okay, we say that the variable saves only 8 precise digits. So 8 precise digits are these ones over here. This is within the expected accuracy of a 32-bit long float. Using a double, which is usually 64 bits long, guarantees that the variable will save a more significant number of digits, about 15 to 17. This is where the name double comes from. Its accuracy is doubled compared to float. Okay, floats and their traits. We told you some time ago that computer addition is not always commutative. Do you know why? Imagine that you have to add a large number of floating point values. Some of them are very large, some very small, close to 0. If a very small float value is added to another that's very large, the results can be quite surprising. Let's go back to the previous example. We assume that our computer only saves 8 precise digits of any float. If we add these two floats, we'll probably get something that looks kind of corrupted as a result. Okay, this lower value simply vanished without a trace. So after 8 digits, it gets imprecise. We can't avoid these effects if we add or subtract the numbers of type float and of double as well, because they're also affected by this issue. The phenomenon described here is what we call a numerical anomaly. In conclusion, the C language does not allow the use of short and unsigned modifiers alongside the types float and double. So short and unsigned cannot be used with float and double. This is something we need to keep in mind here. Oh, okay, this is the number they were talking about before. So if you add this number to this other number, then it gets really garbled because it only keeps track of the first 8 digits in the larger number. Alright. Okay, so familiarize the student with big integer numbers, simple integer computations, conditional statements, and printing on screen. So the most popular human-readable way to write an IP, to be precise IPv4, is to write 4 numbers separated with dots. For example, 127.0.0.1, but an IP address can also be written as a 32-bit number. So to get this form, you must multiply all the parts of the IP numbers by powers of 256. So 256 times 256 times 256, and then multiply by 256, and then 256, and then multiply by 256, and then multiply by 1. Don't use pre-computed versions. Okay, write a program that asks the user to provide 4 numbers, and then checks if these numbers are more than or equal to 0, and less than or equal to 255. Next, the program should write both forms of the IP address, the human-readable one and the 32-bit number one. Use the unsigned long int type. Use the unsigned long int type. To print it, use the %LU. So LU, I guess, is the long unsigned. Long unsigned is LU. Format in the printf function. If any of the address parts don't meet the given criteria, so 0, is less than or equal to x is greater than 255, print only this simple error message. Incorrect IP address, but there's a spelling error in here. So your version of the program must print the same results as the expected output. So for example, sample input 127.0.0.1, expected output would be human readable IP address is this. IP address as a 32-bit number is this really big number. Okay. Alright, so I guess we'll create our program then. So the first thing is, what was it? Scanf. I guess there are 4 numbers that are being asked to be inputted in here, right? So it's so first number, and I guess we'll declare that is a, what do they want? Use the unsigned long type int to print it. So this is to print it unsigned long. So I mean, we don't necessarily need everything to be an unsigned long, but I guess we could also just make these things like unsigned, right? Unsigned, like integer is implied. No, integer is not implied. So unsigned int first num, and then we've got unsigned int second num, and unsigned int third. Specify type always in C. Yeah, unless it's implied. Fourth num. Okay, and what are some other variables we're going to be using? So the unsigned integers are fine. We're also going to be adding everything together in a long. So unsigned long, and we're going to call that 32-bit. Because it's going to be the 32-bit version of the address. Okay, so we're going to need some scanf as well, right? Scanf. Although I guess we can put all the scanf together. So these are just our variable declarations over here. This next part is going to be asking for the user input. So scanf, we're going to be doing it 4 times. because we're going to be recording 4 different octets. So how do we do this again? Provide the first number of the IP address. And we're going to be saving this to firstnum. I think it was done like this. I don't really remember what the syntax looks like anymore. But if it doesn't look like this, then I'm gonna have to look up how to do scanf again. Okay, and scanf format is equal to printf format. Scanf format is equal to printf format. So I think, well, I mean, if it's equal to printf format, then I think this is the correct format. So afterwards, we need to check incorrect IP address. So incorrect IP address. So we have to do the check. We have to do the check after all the input has been taken in. So that after all our scanf, we'll do our if conditional. So if firstnum, so okay. If firstnum is less than 0, what was it, or? So this is or, firstnum is greater than 255, then do something. Although I guess we could also like do this as one giant like if or statement. So if this or this or this or this or this. So checking like first num, second num, third num, and fourth num. And it's going to be a bit like hard to. It's going to be a bit hard to read, but it's also better than having to write them all on different lines over and over again. Okay, so we got fourth number and fourth number, and then third number and third number, and then second number and second number. So like this. So first number, second number, second number. If all of these conditions are true, then we do puts the error message incorrect IP address. And then break, but they didn't teach us break. So no, I guess this would be the if else. So if this, else do something else, right? So else And I guess for else, we can do return would also exit the routine. I mean, I think we're okay not doing return in this case, because there's only two possibilities. It's either the numbers are in range and we can do the calculation and print out the stuff, or we can't. But I guess we're doing multiple things in this case, so I think we need to put everything between some code blocks. So we put else, (32) 32-bit 32-bit equals first num times, what was it, 256? It's like times 256 times 256. Yeah. So first num times, well, I mean, I guess we can put everything between some brackets just to make it a little bit more organized. So times 256 times 256 times, it's multiplied by 3, right? So the first one is multiplied by 3, and then the second one by 2, and then the third one by 1, and then the fourth one by itself. So 32-bit equals first number plus second number times, let's just copy paste. So it's 256 times 256, and then third num just multiplied by 256 by itself, and then plus fourth num. Okay, so we make the declaration right there, and then we print out the message. So printf human readable IP address is human readable IP address is, let's see, so these are going to be Ds, so digits, so D dot D dot D dot D, and that's going to be first num, second num, third num. Cybersky, hello, nice to see you here. We're just doing some C coding. We're learning about all sorts of great things in C. And if you want to join us, we're currently doing this course. Okay, first num, second num, third num, fourth num. And then we have to print out another message. I suppose after this thing, we're gonna do the /n, so we have our line break. We're gonna printf the other thing. Oops. So the other one is going to be IP address as a 32-bit number, and it's going to be, what was it, unsigned long, so UL, and it's going to be 32-bit. Okay, Cybersky says, I see you made some progress between the last C language session. Yeah, we managed to finish up our section on, what were we talking about again? I can't even remember, but we're doing loops now. We're doing loops and we're doing like if statements, although we haven't come across our loop section yet. I'm sure it'll come soon. Oh, it's LU, not UL. Okay, gotta make sure. LU for unsigned long integer type. Okay, and I think this should be it. Okay, let's try running the program. Let's see. So this is line 13, 8 too many arguments for format. Too many arguments for format. Okay, so hold on. Let me take a look at the scanf syntax. C scanf syntax. Okay, the function is defined in standard io.h. Do we have it? Standard io.h, okay, we have that. Scanf, it didn't like this. Too many arguments for the format. Okay, int scanf. Int scanf. What? Practical usage syntax. For standard application, the syntax looks like this. Scanf, format specifiers, and variable 1 and variable 2, etc., etc. Address of operator. This symbol must precede your variables except for strings and arrays. It passes the memory address of the variables, so scanf can store the data directly into it. Okay, so what's wrong with my syntax? Please provide the first number of the IP address and first num, and first num, and second num, and third num, and fourth num. Too many arguments for format. But there's only one argument. Unless I've got something terribly wrong. No percent value. Oh! Are we supposed to put a percent value? In here? Format specifier is a text string containing the placeholders to tell scanf what type of data to expect from the user. So we would do format specifiers. Oh, no. So, okay. I think I understand. So this has to be, this is not a message. This is just the format specifier. Yeah. It's not a print statement. I got that wrong. So this should be puts. So I need to cut this out, and I need to make this puts like this. And this has to be %d. Okay, and then scanf. Well, let's just replace all these first. So these all go away, and these all get replaced by %d. Okay, so puts and so this is first, second, third, fourth. Gotta spell fourth correctly, please. Third, second, okay, so %d, save to first num, save to second num, save to third num, save to fourth num. So apparently 1, 2, 3, 4, these were the only errors. So I think we can just run the code after this. Format %d expects argument of type int, but argument... Format %d expects argument of type int, but argument scanf d and first num. Huh. Has type unsigned int, but argument 2 has type unsigned int. Argument 2 has type unsigned int. Oh, is this because we eventually use this? Oh, no. Okay. So let's just specify that these are all just regular integers and not unsigned ones. Okay, and then we'll try again. Run the program. Pull the lever, Kronk. Provide the first IP address. First number of the IP address. Oh, I forgot. I forgot that puts automatically includes the line break, so we don't need to include those. So let's just exit out of here. Oh, this is in the middle of execution. Okay, let's get rid of these line breaks. I forgot that puts includes the line breaks. Hack Smarter Not Harder, hello, nice to see you here. XJRTV, Hack Smarter has just rated the channel at 17 viewers. Hey everybody, do you know that Hack Smarter has a Twitch channel and a YouTube channel? Let's give a shout out to Hack Smarter. Shout out Hack Smarter. Okay, and welcome in Raiders. My name is the Shy Hat, and we're doing cybersecurity, co-working, and hangout. Thank you very much for following XJRTV. Thank you. Nullsec, hey, what's up? What's up? And Isivanov is Ivanov. Hello, nice to see you here. And John Doe, thank you very much for coming in. And a hacking platform. Yes, also a hacking platform. Nullsec, hello, nice to see you here on YouTube as well. So yeah, we're currently doing a C coding course over here. It is free, and it's 30 hours of content if you want to learn about the C programming language. I usually do more structured cybersecurity streams, but today is a co-working stream. So we're going to be learning about C coding stuff, and if you want to do some co-working and work on your own stuff at the same time, please feel free to do that. Okay, but what were you doing over at Hack Smarter? We're going to be covering some Hack Smarter later on this week, actually. So we're going to be doing Hack Smarter Dark, the Linux CTF box, and don't tell me you guys were doing Dark over at Hack Smarter. Active Directory stuff. Oh, okay. Awesome. Yeah, always up for Active Directory stuff. Okay, we just released a free web app lab 2 called Health Smarter. Awesome. I'll have to put that on my schedule. I'll have to put mine on my schedule for next time. Thank you very much for letting me know about that. But yeah, Hack Smarter has a platform called the Hack Smarter Platform, strangely enough. And there's all sorts of great cybersecurity education modules over there if you want to check it out. Over at this link. Okay, let's get back to the coding. We're trying to figure out how to code in C. Sorry I'm late. Tyler derating while mentioned you were streaming. Thank you very much, Nullsec. Thank you very much. Much appreciated. But yeah, we're just slowly making our way through this coding course. So we're trying to figure out a program that prints out IP addresses in both their human readable form and in their 32-bit integer form. Provide the first number of the IP address. So they want 127.0.0.1, 0.0.1. Human readable IP address is 127.0.0.1. IP address is the 32-bit number is this big number. Okay, the big numbers match. Awesome. Okay. Donald Eki says, what do you think about being software engineers and emergent technologies and wanting the OSCP? What do you think about being software engineers and emergent technologies and wanting the OSCP? I mean, if you want the OSCP, then you're probably interested in network service hacking. Either network service hacking or web app hacking. It's only going to help. You mean being a software engineer and doing the OSCP at the same time? I mean, I'd say that you've got... Yeah, it's only going to help. It's not going to be a hindrance to you. I mean, if you are already a software engineer and you're taking the OSCP course, it's certainly going to help. Okay, so we'll clear this, and then we'll put in the second sample input. Run the program again. Provide the first number of the IP address, 192.168.1.1. So in this case, the IP address is a 32-bit number is not the same number here. Huh. What happened to the math? The math got a little bit wonky. So 192.168.1.1. Let's go back. Use the unsigned long integer type to print it. So we got integer first number, integer first second number, integer third number, integer fourth number. And we got our unsigned long 32-bit. Is this supposed to be unsigned? I mean, I'm sure they wanted us to make it unsigned, right? Next, the program should write both forms of the IP address, the human readable one and the 32-bit number one. Use the unsigned long int type. To print it, use the LU format in the printf function. So we did that. We did that down here. So we print out 32-bit, which we defined over here. So it's going to be first number multiplied by 256, 256, 256, and then second number multiplied by 256 times 2, and then third number just multiplied by 256 and the fourth number by itself. But for some reason, the math went wonky when we tried to print out the long unsigned 32-bit over here. So I'm not too sure why our program is misbehaving. Unsigned long int. And we declared unsigned long over here, so 32-bit. Can you turn the music down just a smidge? Yeah, I can do that. So do we need to make all the other integers... Do we need to change all the other integers to long integers as well, if we want to do math with them? I mean, we can give that a try. So we'll do long int, long int, long int. I guess we can also define these as unsigned long ints as well. Because I think it might be getting strung up on the fact that not everything that's involved in the mathematical operations are the same type. Okay, so we also have to change this in the scanf. So this is going to be unsigned, long unsigned. And that means we have to change all of these D's to long unsigns as well. Okay, and I think, I mean, that might solve the problem. Let's give it a try. So they want us to do 192, 168, 11. 192, 192, 168, 11. Okay, now we've got the proper math. So the proper numbers are coming out, so it's the correct one. So I guess when you use long integer types, you need to do the math with them with other long integer types, otherwise something bad will happen. Okay, we'll run it again. They want 1, 268, 1, and 1. Incorrect IP address. So it doesn't pass the test because these all need to be less than 255. Hanky Lodwig, hi, what are you doing today? So we're just doing some studying right now. We're going to be studying for another 2 hours or so. And we're doing a course on C coding basics. So why are we studying C coding? Because C coding is something that you need to know if you want to do binary exploitation as well as reverse engineering. Because reverse engineering software, when they do their decompilation, what was it? Yeah, decompilation will decompile all of your binary code to pseudo C code. So you should be familiar with C code in order to make sense of it. As well, a lot of beginner binary exploitation challenges are written in C, and it's taking advantage of a lot of the insecure functions in C to do your binary exploitation. Okay, so we're done. We're done with this one. Metamorphosis or conversion of data. A multitude of data types in the C language can cause some confusion, especially when different data types appear together inside one expression. Now it's time to talk about this thoroughly. Let's start with the definition. Changing the type of the data, perhaps combined with a change of its value, which may cause a loss of accuracy, is called a conversion. The C language knows two types of conversions. Hanky Lodwig says, I see, that's what I want to learn. Hanky, you do reverse engineering, don't you? You do reverse engineering, you also do like binary exploitation stuff? I think you've mentioned stuff about that in the past. Okay, so the C language knows two types of conversions. There's implicit conversions, which work according to language rules and are not specified in the code in any visible way. Their operation is silent and automatic. And there's explicit conversions, carried out at the developer's request. The developer should insert them explicitly inside the code, indicating which value should be converted and into which resulting type. Implicit conversions are performed at runtime according to these strict rules. The rules are applied in the order below until all the data used in the particular expression has the same type. This condition is very important. Okay, data of type character or short int will be converted to type int. This is called an integer promotion. Okay, SysOS says, I'm going to rewatch this later. Good luck learning C. Thank you very much, SysOS, and hope you can get some good rest. Phaser Prime says, productive people in the chat. It's good to be productive when you can be. Phaser Prime for sure. Hanky says, yep, got to learn about heap memory exploits. Yeah, I'd love to learn more about stack and heap overflows and stuff. This is why we're studying. If there's any value of the type float in the expression, the other data will be converted to float. So this is to ensure that if you've got decimal numbers in any calculations, then other data has to be converted to float as well. So if there's any value of type double in the expression, the other type will be converted to double. This is good. If there's any value of long int in the expression, the other data will be converted to long int. So in the context in which the expression is calculated requires another type than the one resulting from the implicit conversions, the last conversion is done to the type that is requested by the context. Okay, explicit conversions are introduced into the code using the typecast operator. So this is a unary operator with high priority, equal to unary minus priority. You can see it here. So type and then value, where type is the name or description of the type, which the value will be converted into. So for example, in the following snippet, the variable x of the type float is explicitly converted into a double type. Okay, float x double y equals double x. Okay, so y equals the double type of x. Because initially float is declared as x is declared as a float, and then y becomes explicitly the double interpretation of x. Because we were introduced a new operator, we need to update the priority table. So typecasting is on the same priority as incrementing, decrementing, and then declaring something as a positive or negative integer. And then the next order of operations is multiplication, division, and modulo. And then we've got our addition, subtraction, and then we've got our greater than, less than, and then greater than or equal, less than or equal to. And then we've got our is equal to comparison operators and not equal to. And then we've got our these other ones over here. Okay, let's move on. Typecasting continued. Knowing how implicit conversions, sometimes called automatic, how they work, we'll analyze the process of calculating the value of the expression in the following snippet. Okay, let's take a close look. Whoops. Okay, integer int, character, short, float. Integer equals short plus character plus float. Okay, we can predict the following implicit conversions will take place. So because there's a float involved, everything else will also become a float. So character will become a float, and then short will become a float, and then by definition int will also become a float. Okay, promotions go first, resulting in the following conversions. So integer short plus integer character. So characters become integers. So the sum of short and character as well as the float variable will be converted to the float, which is float integer short plus integer character plus float. So basically everything becomes a float. So the final sum will be calculated as a float because of the context arising from the type of the left argument of the equals operator, which is int. Another conversion into an int type takes place, hence the final form of the expression looks like this. So integer cast into float, cast into an integer short plus integer character plus float. Some simple programs. Now we're going to show you some simple yet complete programs. We won't explain them in detail because we think the comments inside the code should be enough for you to get it. All the programs perform the same task. They find the largest of several numbers and print it out. Let's start with the simplest case. How to identify the larger of two numbers. Okay, finding the larger of two numbers. So int main void, two numbers, int number 1, number 2. We will save the larger number here, int max. Okay, read two numbers, scanf number 1, scanf number 2. We'll temporarily assume that the first number is the larger one. We will check it soon. Max equals number 1. So we use number 1 as the placeholder. We check if the assumption was true. If number 2 is less than max, if number 2 is greater than max, then max equals number 2. Okay, and then we print the result. Printf, the largest number is %d, so digit max. then we finish the program successfully. Okay, so I guess what I'd like to do here is I'd like to put in a little message. So we could do puts, something like enter first number, and then enter second number. Okay, something like this, and we'll run the program. So enter first number, we'll do 10. Enter second number, we'll do 5. And then the largest number is 10. So, I mean, this program seems to be working. We can move on. Okay, let's try to find the largest of the largest of 3 numbers. We find the larger of the first two, and then compare it with the third one. Here we go. Okay, so finding the largest of 3 numbers. So we got integers number 1, number 2, number 3. We will save the largest number here. So int max, read the 3 numbers. So once again, I'd like to put in some messages before we take in user input, because otherwise it can become a bit confusing. Enter the first number, and then second number, then third number. Okay, so we will temporarily assume that the first number is the largest one. We will check it soon. So max equals number 1. We check if the second value is the largest. So if number 2 is greater than max, then max equals number 2. And we check if the third value is the largest. If number 3 is greater than max, then max equals number 3. Then we print the result. The largest number is digit max. Okay, so let's try running the program then. Enter the first number. So we got 10, we've got 30, and we got 999. And it says the largest number is 999, so this is how the program working as expected. Okay, we can move on. So you should be able to write a program that searches for the largest of 4, 5, 6, or even 10 numbers. You already know the format, so extending the program isn't particularly complex. But what happens if we ask you to write a program to search for the largest of 100 numbers? Can you imagine the code? You'll need hundreds of declarations of type int variables. If you think you can cope with that, then try to imagine searching for the greatest of 1,000,000 numbers. Imagine the code that contains 99 conditional statements and 100 invocations of the scanf function. That doesn't seem like a lot of fun. Okay, let's ignore the C language for a moment and try to analyze the program without thinking about the programming. In other words, let's write the algorithm, and when we're happy with that, we'll implement it. We'll use a kind of notation which isn't a programming language at all. It can be neither compiled nor executed, but it is formalized, concise, and readable. We'll call it pseudocode. In the editor, there's an example of pseudocode. What's happening in it? Okay, so 1 max is equal to negative this really big number. Read the number. If number is equal to -1, print max, next stop. If number is greater than max, max equals the number. Go to 2. Okay, so this is a loop. So it reads in the number. If it's not this, then it runs the loop. It goes back. Okay, makes sense. First, we can simplify our program if at the very beginning of the code we assign the variable max with the value which is smaller than any of the numbers entered. Okay, so the max is the smallest number possible. Second, we assume that our algorithm doesn't know in advance how many numbers will be delivered to the program. We expect the user will enter as many numbers as he or she wants. The algorithm will work well with either 100 or 1,000 numbers, but how do we do that? We'll make a deal with the user. When the value -1 is entered, it'll be a sign that there's no more data and the program should end its work. Otherwise, if the value entered is not equal to -1, the program will read in another number and so on. The trick is based on the assumption that any part of the code can be performed more than once, in fact as many times as needed. Performing a certain part of the code more than once is called a loop. You probably know what this means already. See steps 2 through 5 to make a loop. Can we use a similar structure in the program written in the C language? Yes, we can, and we'll tell you about that soon. Okay. Alright, we can move on. So familiarize the student with type conversions, conditional statements, integer numbers, floating point numbers, getting input from the user, and printing on screen. Write a program that takes one floating point number, converts it to an integer number, and then prints a description of the given number. Descriptions for numbers. Numbers greater than or equal to 1 and less than 2, very bad. Numbers greater than or equal to 2 and less than 3, bad. Numbers greater than or equal to 3 and less than 4, neutral. Numbers greater than or equal to 4 and less than 5, good. Numbers greater than or equal to 5 and less than 6, very good. So when a number is out of the given range, the program should print nothing. Your version of the program must print the same result as the expected output. So for example, if you got 1.5, then the expected output is very bad. If you put in 2.9, the expected output is bad. 4.7 is good. Okay, all right. I think we can write the program. Okay, takes one floating point number, converts it into an integer number. So I guess the first thing we need to do is we need to declare our integers. So we'll call it the float because we're dealing with a floating point number. So we'll call it a float the float. And what else do we need to do here? We need to do some puts. So we need to print out a little message. And this is what we expect the user to do. Enter a floating point number. A floating point number, for example, 2.5. Whoops. Enter a floating point number, for example, 2.5. I guess we can put that between some parentheses, like this. Okay, and then we'll do the scanf to record the input. So recording a floating point number. The float. So the next thing we need to do is we need to do the comparison operation. I guess we can also declare like converted. The float converted to like an integer. So we'll call this like int convert. And this is an integer. Okay, and what are we doing now? So the conversion is, I guess we can, do we do the conversion before we do anything else, before we do the comparison? I guess we should do the conversion first. So, like integer of Or like int convert equals integer of the float, like this. That's how you do the typecasting, right? Okay, and then we do the comparison. If int convert is what was it? Less than or equal to greater than or equal to 1 and less than 2. Greater than or equal to 1. So greater than equal to 1 like this. And less than 2. Then we need to print what puts. Puts very bad. Okay, else if puts, well, all the other messages. How many of these are there? So 2, 3, 4, 5. So 5. 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, and then else. So these all need to be else if. There's not going to be like a strict else. Actually, I guess else. So we're doing these different comparisons. For int convert. And we're printing out these different messages. So the last one is very good. The second to last one is good. And then neutral. And then bad. So what's the second criteria? Greater than or equal to 2 and less than 3. Okay, so greater than or equal to, I guess it's 2, 3, 4, 5. 1, 2, 3, 4, 5. There should be 5 total. 1, 2, 3, 4, 5. Numbers that are equal than, greater than or equal to 5 and less than 6. Okay, so I think this will do the job. When a number is out of the given range, the program should print nothing. So I'm pretty sure the code as is over here is not going to print anything if we put in like 6. And let's go ahead and run the program and see if it works. Invalid operands to binary AND have character scanf. Character and scanf. Hold on. So float the float, integer int convert. Puts enter a floating point number, and then we save it to the float. And the error comes on line 10. So %f is floating point number, isn't it? Invalid operands to binary AND. %f. Hold on. What is it called? Like C type. What are they called again? C type %f. Okay. float or double data digits by default displays a floating point number exactly 6 digits of precision. Okay. What problem do they have with the program? Invalid operands to binary and... Oh, okay. I forgot to put in the comma here. So you need to be very precise when you're doing this stuff, otherwise it'll screw up. Okay, run it again. Enter a floating point number. So we do 1.5. Very bad, okay? And then we'll run it again with 2.9. Something went wrong. So 2.9 should result in bad because it should be converted to 2.9 should be converted to 2. But instead so 2, 3, 4, 5. Okay, let me just do a little bit of debugging here. So we put in 4.77. It still puts out very bad. Okay, so obviously there's something wrong with the program. Let me read about typecasting again. C typecast float to int. To cast a float to an int in C, put in the parentheses int directly before the float variable or expression. So my float equals this, okay? And then int my int equals int of my float, explicit typecasting. Int of my float. Let's go back. So I think I might have done something a bit weird with the, so it should be like this. So the int convert should be int of the float. We'll run this and see what happens. So they're looking for 2.9 and it should output bad. 2.9 still outputs very bad. So there's something wrong. So if int convert is this should be less than or equal to 1. Sorry, less than or equal to 1, less than or equal to 5. Yeah, no, I screwed this up. All right, let's try it again. 2.9, bad. Okay, so that's the expected one. And then we'll do the last one, 4.77. That's another big typo on my part. Okay, 4.77. Good. Okay, so we've managed to successfully put out what they want us to put out. Okay, so let's see. Type conversions, conditional statements, fixing errors in program, integer numbers, floating point numbers printing on screen. Check the program in the editor, find all possible compilation errors and logic errors, fix them. Your version of the program must print the same result as the expected output. Okay, use the converted number to check how to round a float number. Use the converted number to check how to round a float number. So 5 is 5, rounded to 7 equals 7. Okay, so let's go ahead and check the code for potential errors. So what's going on here? So float not exact 5 is 5.7. Float not exact number equals 6.7. Integer exact 5, integer rounded number. So if not exact number minus if not exact number minus not exact number is greater than, is greater than 0.5. So rounded number equals integer of not exact number plus 1. So we're checking rounding, so everything that is 0.5 or over is going to be rounded up, and otherwise it's going to be rounded down. So when we do explicit conversions of floats, then they're going to be rounded down by default. Okay, not exact number, integer cast of not exact number plus 1, and that's going to become the rounded number. Else, rounded number equals integer of not exact number. Okay, so this should be between some of these, otherwise it's not going to work. Okay, exact 5 equals the integer cast of not exact 5. Okay, 5 is 5. Rounded to 7 is rounded number. Let's see if we can print this out. Okay, warning format expects argument of type double. 5, oh, exact 5. What's going on here? Okay, so I think this is incorrect. This should be a D instead of an F, because exact 5 is an integer. Okay, so let's see if this works now. Pull the lever, Kronk. What? Not exact number. This is line 9. So okay. So when you do comparisons in C, you need to make sure that the comparison is, well, if you do an if statement, the stuff that you're comparing has to be inside the parentheses. Otherwise, it doesn't work. Okay, and we'll try doing that again. Five is 5. Rounded to 7 is 6. Rounded to 7 is 6. What happened here? So not exact number. Okay, not exact number is 6.7. We need to make sure that this becomes 7 after it's rounded. So not exact number. If not exact number minus not exact number is greater than, so not exact number is 6. Oh, okay. So we need to put some casting in here as well. So it's going to be not exact number minus the integer of not exact number, like this. Otherwise it doesn't get properly calculated. Okay, and we'll run it again. 5 is 5, rounded to 7 is 7 now. Okay, so we've got the correct code. We'll move on. The while loop. We'll ask you a strange question. How long do you usually take to wash your hands? Don't think about it, just answer. So how long does it take to wash your hands? So that's going to be 30 seconds? Well, when your hands are very dirty, you wash them for a very long time. Otherwise, it takes less time. Then you keep washing your hands until they're clean. Trick question? I don't. Well, I guess people can have preferences. Look at the statement below. Do you agree with it? While my hands are dirty, I am washing my hands. I mean, this seems logical enough. Note, this also implies that if our hands are clean, we won't wash them at all. So now you've learned one of the loops available in the C language. In general, the loop manifests itself as follows. So while conditional statement, do the thing. Okay, if you've noticed some similarities to the if instruction, good job. In fact, there's only one syntactic difference. We use the word while instead of if. The semantic difference, however, is more important. When the condition is met, if performs its statement once, while repeats the execution as long as the condition evaluates to true. Okay, look at the concept of the while loop below. While, conditional statement, first instruction, second instruction, on and on and on, okay? So let's make a few observations. If you want while to execute more than one statement, you must, like with the if statement, use a block. Take a look at the code in the editor. An instruction or instructions executed in the loop are called the loop's body. If the condition is false, equal to 0, as early as when it's tested for the first time, the body is not executed even once. Note the analogy of not having to wash your hands if they're not dirty. The body should be able to change the condition value because if the condition is true at the beginning, the body might run continuously to infinity. Notice that washing changes the state of impurity. Washing changes the state of impurity. Here's an example of a loop that can't finish its execution. While true, print f I am stuck inside a loop. Okay? The loop will infinitely print I am stuck inside a loop on the screen. Alright, we don't want infinite loops. Let's go back to sketch the algorithm we made recently. We'll show you how to use this newly learned loop. By the way, we'll introduce one more thing to you. So far we've declared variables in one place and assigned values to them in another. We can combine these two steps by declaring the variable and assigning the value at the same time. We do this by adding the equal sign followed by the expression whose value is assigned to the variable as the time of its creation. For example, if you need a variable that needs a value of 0, you can do this. Int variable equals 0. As usual on such occasions, a new word arrives in our vocabulary. The part of the declaration placed on the right side of the equal sign is called the initiator. Okay, on the right side of the equal sign, so right here, this is the initiator. Okay, the initiator you saw before was a literal, but we can also use complex expressions like these ones. So float pi equals 3.1415, double pi 2 equals 2.0 times pi. Okay, we'll be using initiators often. They're extremely convenient and quite useful. Okay, a simple program. Look at the code inside the editor and analyze it carefully. Locate the loop's body and find out how the body is exited. This program continuously takes numbers as input from the user until -1 is entered. During this process, it keeps track of the largest number entered. After the user finishes entering numbers, it prints the largest number among the input values. Think of using -1 as a sentinel value that signals the end of input. Okay, see how the code implements the algorithm we made earlier. Okay, so let's see, we've got our main function over here. So int number, we will store the current greatest number here. So maximum equals minus, is that that's 100,000, okay, negative 100,000. Get the first value. So scan f and save it to number. If the number is not equal to -1, we will continue. While number is not -1, is the number greater than the max? If number is greater than max, then upgrade max. Max equals number. Get the next number. Scan f, okay, and number. And then after the loop is exited, and we can only exit the loop if the number is -1. Okay, and then print the largest number. Print f, the largest number is something, max. Finish the program. Okay, so let's go ahead and run the program. Okay, so it's waiting for input, so we'll do 1, 2, 3, 9999, and then we'll finish the program with -1. And it says the largest number is 9999. Okay, so it looks like it was able to run successfully. So we've got a while loop here. So while number is not -1, and the user gets to decide when the loop ends by typing in -1 as the number. Okay, another simple program. The program counts odd and even numbers coming from the keyboard. Take a look at the code in the editor. Certain snippets can be simplified without changing the program's behavior. Take a look at the next slide. Okay, let's take a look. The program reads a sequence of numbers and counts how many numbers are even and odd. The program terminates when 0 is entered. Okay, so the main function is here. Count the numbers here. Integer, evens, odds. So evens is initiated to 0 and odds is initiated to 0. Store the incoming numbers here. Integer, number. Read the first number. So take in user input and save it as an integer and save that to the integer variable. So 0 terminates execution. So our while loop is over here. While number is not 0, check if the number is odd. If number modulo 2, okay, if number modulo 2 is equal to 0, so that would be increasing the odd counter. Okay, else increase the even counter. So if number modulo 0, so number modulo 0 is just going to divide the number by 0, sorry, divide the number by 2. And if the result after the modulo operation is 1, which is true, then we increase the odds counter. Otherwise, we increase the evens counter. Okay, and then eventually the user is going to input 0, and then we will end the loop, and then print out even numbers this, odd numbers this. Okay, let's run the program. So we're just going to put in 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So all of these odd numbers. Okay, and then finally we input 0. Even numbers 0, odd numbers 8. Okay, so I think this is what they wanted from us. We'll move on. Try to recall how the C language interprets the truth of condition, and note that these two forms are equivalent. So while number is not 0, and while number. Ah, okay, that's interesting. So while number is not 0 means while number is true, and while number is true because 0 is false. So while number is not false, and that's equivalent to while number, which means while number is not 0, basically. So now the condition that checks if the number is odd can be coded like this. If number modulo 2 is equal to 1. If number modulo 2. So we saw this in the code in the previous program there. So if number modulo 0. So we're looking for number modulo 2. And we need to make sure that it's not 0. So because 0 equals false, and anything that's not 0 is true. Nothing would surprise you now, right? But there are two things that can be written more compactly. First the condition of the while loop. So int counter equals 5. While counter is not 0. Puts I am an awesome program. Counter minus minus. Okay, so it's keeping track of whether or not to escape the loop by looking at the counter. So the first time the loop is run, counter is 5, and then they reduce the counter by 1. Then counter is 4, then 3, then 2, then 1, then 0. and when counter equals 0, then the loop exits. Another change requires some knowledge of how post-decrement works. We can use it to compact our program once again. So integer counter equals 5, while counter basically means while counter is not 0. While counter is a value that's not 0, which means true. Puts I am an awesome program, counter minus minus. Okay, so it's basically the same program as the one we saw before, except they don't explicitly say that while counter is not 0. We believe this is the simplest form of the program, but you can challenge us if you dare. What is this? So integer counter equals 5, while counter minus minus puts I am an awesome program. So it basically shortcuts the counter minus minus over here by putting the counter decrement inside of the while loop. So that's interesting. I haven't really seen that before. The do loop, or do at least once. You already know that the while loop has two important features. It checks the condition before entering the body. The body will not be entered if the condition is false. These two properties can often cause unnecessary complications. For this reason, there's another loop in the C language, which acts as a mirror of the while loop. We say so because in that loop, the condition is checked at the end of the body execution. The loop's body is executed at least once, even if the condition is not met. So this loop is called the do loop. Its simplified syntax is presented below. So do statement while condition. Do statement while condition. So do instruction 1, 2, 3, 4, 5 while condition. If you want to execute a body containing more than one statement, you have to use a block, okay? Let's go back to the program to search for the largest number. Firstly, we'll use the do loop instead of the while loop for teaching purposes. Secondly, we'll remove the vulnerability involved in excessively trusting the user's good intentions. Our new program won't be misled by entering the value of -1 as the first number. The program is presented below. Okay, so what's happening here? So main function, integer number, integer max, integer counter. So it looks like we're going to be keeping track of this counter to check if we need to exit the loop. Do, scanf, and save to number. If number is not -1, then counter ++. Okay, if number is greater than max, then max equals the number. While number is not -1, if counter is, so we're looking at if counter is not 0. So counter is initiated to 0. Counter is initiated to 0. If counter printf, the largest number is this, max. Else print, hey, you haven't entered any number, return 0. So take a look, we've used the counter variable to count the numbers entered so that we can tell the user that we can't search for the greatest number if there's no number given. As we have to read at least one number, it makes sense to use a do loop. This is what we've done here. Okay, so, okay, I see. It increments, otherwise it prints the message. So it increments if the number is not -1. Although I guess if you don't put in any number, then counter is going to be equal to 0, and then we print out that message. This one right here. You haven't entered any number. Okay, we've used the counter variable to count the numbers entered so we can tell the user that we can't search for the greatest number if no number is given. As we have to read at least one number, it makes sense to use the do loop. This is what we've done here. The for loop. The last kind of loop available in the C language comes from the observation that sometimes it's more important to count the turns of the loop, the iterations, to check the conditions. Imagine that a loop's body needs to be executed exactly 100 times. If you'd like to use the while loop to do that, it may look like this. So int I equals 0. While I is less than 100, the body goes here, and then increment I. So we can distinguish three independent elements here. Initialization of the counter, I equals 0, checking the condition, I is less than 100, and modifying the counter, I increment. We can provide something like a generalized scheme for these kind of loops. Here it is. Initialization, while checking, the body goes here, modifying. So initialization of the variable here, while loop, what to check for, and then modifying the end variable, progressing towards the end of the loop. This way of coding the loop is very common, so there's a special, very brief way of writing it in the C language. All three decisive parts are generated together. The loop is clear and easy to read. It's called for. So for initialization, checking, modifying, the body goes here. So it may take the following form. For I equals 0, so the variable to check for, and then the check is I is less than 100, and then the modification is I++. The variable for counting the loop's turns is often called the control variable. Okay? The for loop has an interesting singularity. If we omit any of its three components, it's presumed that there is 1 there instead. So for blank, 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 the body goes here. One of the consequences of this is that a loop written this way is an infinite loop. Can you explain why? So the iterator is 1, and it checks that I is true, and I is true if it's 1. And then there's nothing that I mean, if it progresses, if the thing is incremented, then it never becomes false, because there's nothing that will either equate explicitly true or false. Then this loop goes on forever. The conditional expression is not there, so it's automatically assumed to be true. And because the condition never becomes false, the loop becomes infinite. Let's look at a short program in the editor. Its task is to write sum of the first powers of 2. The exp variable is used as a control variable for the loop and indicates the current value of the exponent. The exponentiation itself is replaced by multiplying by 2. Okay? So since 2 to the power of 0 is equal to 1, then 2 times 1 is equal to 2 to the power of 1, and then 2 times 2 to the power of 1 is equal to 2 squared, and so on. Answer this question. What is the greatest exponent for which our program still prints out the result? Okay, let's take a look here. Okay, integer exponent. Exponent integer power equals 1. For exponent equals 0. Exponent is less than 16. Exponent increments. Print 2 to the power of nullsec says 15. I mean, yeah, that makes a lot of sense, since 16 is what it checks for. And when it reaches 16, it doesn't run the loop anymore. Okay, and let's go ahead and run the program. Okay, 2 to the power of blah blah blah, and the last one is 2 to the power of 15. Okay, yeah, that behaves just like we expected to. Break and continue, the loop spices. So far, we've treated the body of the loop as an indivisible and separate sequence of instructions that are performed completely at every turn of the loop. However, the developer could be faced with the following choices. It appears that it's unnecessary to continue the loop as a whole. We should refrain from executing the loop's body and go further. We should refrain from executing the loop's body and go further. It appears that we need to start the condition testing without completing the execution of the current turn. So the C language provides two special instructions for implementing both of these tasks. Let's say, for the sake of accuracy, that their existence in the language is not necessary. An experienced programmer can code any algorithm without such instructions. The famous Dutch computer scientist Edgar Dijkstra proved it in 1965. Additions which don't improve the language's power of expression, but only simplify the developer's work, are sometimes called syntactic candies. Candies? Syntactic candies. These two instructions are break, exits the loop immediately and unconditionally ends the loop's operation. The program begins to execute the nearest instruction after the loop's body. I've never heard that plural. I don't think I've heard of that one either. And continue. Behaves as if the program has suddenly reached the end of the body. The end of the loop's body is reached, the control variable is modified. In the case of for loops, and the condition expression is tested. Both of these words are keywords. Next we'll show you two simple examples. We'll show you their full power soon, okay? We return to our program that recognizes the largest among the numbers entered. We'll convert it twice using both instructions. Analyze the code and judge whether and how you could use any of them. You can see the break variant in the editor. Note that the only way to exit the body is to perform the break, as the loop is infinite, for something something something. Okay, and now the control continue variant. Okay, so let's take a look at the break variant. So int number max equals minus 100,000. Int counter equals 0. So this is an infinite for loop. Scanf d to number. If number is equal to -1, then break. So this is how we break out of the loop. We use this this if statement inside of the loop. Otherwise, the counter goes up. If number is greater than max, then the max is equal to the new number, or the current number. Okay, if counter, print the largest number is something something. Okay, so if counter, this is checking if the counter was incremented. Otherwise, print, are you kidding? You haven't entered any numbers. Okay, and then we'll just we'll run the program. So we'll do nothing. Huh. That's funny. I expected... Oh, wait. What if we do this? I think that breaks the program. Never mind. Okay. Let's run the program again. Okay, it's looking for a number, so we'll do 9. We'll do 9999. We'll do 99999. And then we'll print it, we'll put in -1. And the largest number is 99999. Okay. Okay, move on. And now the continue variant. So what's going on here? So same thing as the previous program. Number, max, and counter. Do scanf to number. If number is equal to -1, continue. So don't run the rest of this loop. And then print this message. The largest number is this. So basically, continue is going to ignore the rest of the loop body. and then skip over to this over here, while number is not equal to -1. And then counter is checking if there was anything, if the counter is not 0. If the counter is not 0, then print the largest number is something something. Okay, run the program. It's looking for a number, 0, 1, 2, 3, the hacker number, and then -1. What happened? Okay, the largest number is the hacker number. Great. Move on. Familiarize the student with logic of loops while, conditional statements getting input from the user, integer numbers printing on screen. So write a program that takes 2 integer numbers and prints their sum. Do this until the user enters 0, but print the last sum. Do this until the user enters 0. Additionally, if the user inputs 99 as the first number and 0 as the second number, just print finish and end the program. Use the while loop in your code. Your version of the program must print the same result as the expected output. Okay, so 1, 1, and then 2 and then 0. So 1 and 1 should result in this, 2. And then 2 and then 0 should end the program, but we still get the sum, which is 2 plus 0. If we put in 1 and 5 and then 99 and 0, then we get the first sum, which is 1 plus 5. 99 and 0 results in sum 99, and then the extra message finish. Okay, let's go ahead and code the program. Okay, so we need to do like first number, and this is going to be in integer. Integer first number, and then integer second number. And then we're going to ask for user input. So puts enter the first number, and then we'll do another one for the second number, and then after each one of these we can scanf to save the results to first number and second number. We will save a digit. And the same thing here, except we're going to save it to second number. Okay, and I guess we'll do our loop here. Oh, we need to do our loop inside of all of this, right? So we'll do something like while true. So how do we want to write our while loop here? So we're writing a while loop. I mean, I guess we can just do while. If the user inputs 99 as the first number and 0 as the second number, just print finish and end the program. Do this until the user enters 0, but print the last sum. Write a program that takes 2 integer numbers and prints their sum. So I mean, I guess we want to just do like while true. enter first number, enter second number. So we'll do the scanf here. And we can do comparison here. So if first number is equal to 0, so we'll do both of these if first number is equal to 0 and if second number is equal to 0. I guess this is going to be like a code block as well. Do this until the user enters 0, but print the last sum. Print the last sum. I guess what we need to do here is we need to initialize first number and second number to 0 at the start of the loop. Okay, so I think we might be able to do this for another hour or so. And then I have to think about wrapping up the stream. Okay, we got 60 minutes. If first number is equal to 0, then printf sum, right? Sum then %d, and we're going to be doing first number plus second number. Okay, same thing here. Need to make sure that our indentation is correct, otherwise, you know, it looks messy. Okay, if first number is equal to 0, print the message and then break. And the same thing here. Print the sum and then break. Yo, C is goated. Hello, NedMac. Nice to see you here. Yeah, we're learning about C. We're learning all of the ins and outs and doing some practice as well. Okay, so print the second number. Print sum, first number, second number, and break. And I guess we'll do another one. So if the second number is 99, then print finish. The only bad part is strings. Yeah, strings are treated as like character arrays, I think. If the user inputs 99 as the first number and 0 as the second number, just print finish and end the program. Just print finish and end the program. So if we do 1 and then 5, sum 6. If it's 99 and then 0, then sum 99, then print finish. How do we incorporate this functionality here? 99 and then 0. So I guess we need to check. So after we break out of the loop, after we break out of the loop, then we do the check if, what was it? If first number is equal to 99 and second number is equal to 0, then run the thing. If num1 equals 99 and num2 equals 0. Yeah. That's what we're trying to do. We have to print puts, right? Puts finish, period. Put that between them some quotes. Okay, otherwise, so we're staying in the loop here. First number, second number, while true, enter the first number, enter the second number. Okay, if not, then printf sum %d line break. I guess we need to put some line breaks in the other ones as well. And it's going to be first number plus second number. And the last thing in the loop is we need to initialize first number and second number to 0. So while true, first number equals 0 and second number equals 0. Okay, I mean, it feels kind of janky, but let's see if the program works. Or if I've got like syntax errors. We'll see. Okay, error true undeclared. First use in this function while true. Oh, okay. So how do we do the while infinite loop? I mean, I'm sure we could do like while 1. Yeah, while 1, right. Yeah. Because 1 equals true. Okay, and then we'll run it. Okay, we got enter the first number. Enter the first number. We've got our expected input and output. So 1, 1, 2, 0. 1, 1. Oh. Uh-oh. There's something wrong in the code. It keeps on going. Okay. I need to exit out of here. Okay, include standard bool h. I mean, if we use 1 instead of true, then I don't think we need it. Okay, so let's take a look at so int first number, int second number, while true, first number equals 0, second number equals 0, puts enter the first number, scanf, take in first number, if first number equals 0, then break, and then enter the second number, Okay, and then check if the second number is not 0. And then printf sum first number is second number. But for some reason it doesn't do that. It doesn't do the printf instruction. So is it outside of the loop? I think this might be outside of the loop. While 1, so where is this matched? Yeah, check indentation. Yeah. Let's do that. So this should be grouped up with this. Oh, I think. Yeah, I think it's in the wrong. My printf instruction is in the wrong place. So scanf puts scanf printf. Yeah, printf needs to go somewhere else. Okay, we'll just cut this. And put it here. This is still inside the loop, right? And I need to put this one outside of the loop over here. Okay, let's try running it again. Enter the first number. Okay, so we got 1, and then 1, sum 2. Okay, and then 2, and then 0. Sum 2, and then it breaks out, and the program finishes. Okay, that's good. So we'll do 1, 5, and then 99 and 0. So let's run it again. 1, 5, 99, 0. So sum 99 and then finish. Okay, so this is what happened. So we did the program correctly. Let's move on. Okay, familiarize the student with logic of loops do while, getting input from the user, printing characters on screen. Write a scenario, write a program that asks the user to enter a number, then the program should print the number of lines corresponding to the number printed, the number inputted. Each line should contain the number of pairs of characters, %# equal to the number on this line. The outputted drawing should be of a similar to the right half of a pyramid. Your version of the program will print the same result as the expected output. To do this lab, you must use 2 do-while loops. However, when the user inputs a number less than or equal to 1, the program should only print 1 line. So when the user inputs a number greater than 20, the program should print only 20 lines. So what's going on here? So if we input 3, then the output should be %#. %#. Okay, something's looks like something's going wrong with my chat program. Not that you all can see anything about. We can't see it. Okay, so print a number of these things. Sample input 5. So if you put in 5, then you should print out 5 of these. If you put in 0, then it's going to print out 1 of these. Okay, to do this lab, you must use 2 do-while loops. Alright, so let's start writing the program. So it's going to be int number, int the number. Okay, and we don't need to initialize this to anything because this is user input. Yeah, do something something while something something. Thank you, Nitmac. So we're gonna do some stuff while some other stuff, like this. Do we need to do this like that? Do we need to put a semicolon over here? So you must use 2 do while loops. I mean, I'm guessing that we need to nest these do while loops in order to get the to get this stuff to come out. Randolph Stokes, hello, nice to see you here. Seems like if number is less than 1, or if number is greater than or equal to 20, then print either 1 or 20 times. And the only difference between a normal while loop and the do while loop is that the do while loop is guaranteed to execute at least once. Yeah, because they're expecting if we put in 0, then it's gonna do something at least once. Nice to see you here, Randolph. Just having a chill little evening here, studying some C language. So do this stuff while like counter, while counter, I guess, because we need to keep track of. So while counter, and then we'll do like integer counter. Counter equals 0. I mean, the number and counter should be initialized to the same number as well, right? Okay. Okay, Randolph says, I do like C and C++, won't stay long, it's past 1 o'clock here. No worries, Randolph, hope you can get some good rest. Okay, so counter, we're going to initialize it to 0, the number we're going to get from user input. So do something. So I guess we'll do puts first. Enter a number. Actually, we're only doing the first one. We're only taking in user input once, right? So we'll also do like a do while loop in here as well. So like do while and then do while, like nested. Military time too, Thanto, hey, nice to see you here. Nice to see you here. I think that's right. Let me check. So C do while loop syntax. Just want to make sure I've got the syntax correct. Okay, do block of code to be executed while condition. So condition, and then we put in, yeah, we got to terminate it with the semicolon. Rana Mucker, nice to see you here. Hope you're having a good day. So do while counter. While counter is not 0. So I guess here we'll also do while counter for this loop as well. So the do while loop only runs once. So this runs once while the one inside it can run multiple times. So let's see, puts enter a number, and then we do the scanf. Because we don't scanf multiple times. We're scanning and we're taking in a digit and we're saving it to the number. Apologies, lurking and misplaced my cursor. No worries, Run-a-Mucker. I'm okay. I'm perfectly okay with lurkers here as well. So we're saving this to the number. Well, I guess the number and counter can be the same thing. So we don't really need the number, because counter kind of serves the same purpose. So we'll just get rid of the number, and we'll just stick with counter, because I don't think we need two. Okay. So enter the number, scanf, take in counter from user input, and then do something something while counter. So they want you to print printf counter So printf and then print out the asterisk and the hash symbol. Print off asterisk and then hash symbol. And then print 2, and then print 3, and then print 4, and then print 5, if we put in 5. Do while counter. Print you need to decrement, I think. Yeah, let's just think about this. So we need to, maybe we need to add another, variable in here. So the counter is going to be counting up, and the other thing is going to be counting the number of repetitions here. So repetitions is going to be equal to, we're also going to initialize this to 0. Okay, so we can initialize this to 0, scanf, and save to counter, and then repetitions is going to be equal to counter. We absolutely need a decrementer simply to count the number of prints. Yeah, I think, well, we can also keep track of the number of prints over here in the repetitions. So repetitions is going to equal to into whatever was put in as the counter. So printf oh, but this counts up. The number of repetitions counts up. So I guess this one is going to be while repetitions is not equal to counter, right? Because we initialize it as 0, but the repetitions are going to go up. The counters, maybe the counter stays the same. So for example, if counter equals 5, then the repetitions are going to multiply the number while the repetitions is not equal to the counter, because we're looking for, I guess it would it be the counter or the counter plus 1? Because it has to happen at least once. While repetitions is not equal to counter plus 1. So we printf this. MKR rocks. Hey, can you look at my one site? Well, I mean, we're here to do some co-working right now. What kind of site are you talking about? I'm too tired for this tonight. No worries, no worries. One variable would be the number 9. One variable would be the number 9. So repetitions equals I guess in this case, repetitions would not equal to counter. Repetitions is initialized to 0. So let's just leave that out. So while counter here, and then while rep is not equal to counter plus 1. So how do we get this to multiply? Can I send after this? I mean, what kind of site are you talking about? MKR rocks. Are you asking us to do security testing on your website? Because unfortunately, we can't really do that because you can't. Because people usually need to get paid to look at to do security work, and B, it can be kind of dicey. What is the word? Confirming that you own the website, because I don't hack random people's websites. Okay, so print this times the counter. Print this. Let's say print it and then. So do printf this thing. There's no multiplication involved. Okay. So print this thing. I guess printf how do we get it? How do we know to it's an AWS, oh, an AWS website. Okay, I mean you can how do we do this on YouTube? So on YouTube you're not allowed to send links. So what you can do is you can try defanging your link. So something like if you were to type in like google.com, https google.com, you need to defang it by putting in a bracket like this. So try doing this kind of format to see if it gets picked up by YouTube, because YouTube doesn't like sending whole links. I guess the other thing you could do is you could also like separate out the HTTPS. You need to, I think we're supposed to multiply the octothorpes. You can also put, you can try doing it like this, so you can defang the URL like that. Give it a try. Okay, let's read the instructions one more time. When the user inputs a number less than or equal to 1, the program should print only one line. When the user inputs a number greater than 20, the program should print only 20 lines. So we need to make sure that the output is capped out at 20. I'll send it into base64. I mean, you could try sending it in base64, yeah. That's an octothorpe. Oh, the hash symbol? I just wanted to use the word. Thanks, nullsec. Okay, do printf this thing, right? While rep is not equal to counter plus 1. So counter plus 1, that'll print off one of these. So the thing is that we want to know when to send the line break and then start anew. Moodle, gotta keep you on your toes. Thank you. Oh, it's an Indonesian website. Are you from Indonesia, MKR Rocks? Oh, it's India. It's not Indonesia. Okay. Oh, Moodle. Interesting. I took a look at Moodle like last week. Was it last? Yeah, it was last week. It was last week. Interesting. So, are you looking for somebody to do like security testing on this? I mean, if you're looking for security testing, you might want to try looking at some like LLM models. I can't do security testing on this website because I can't confirm that you own it. The other thing is that I don't doing security testing on like random websites. It's not really a good idea. Can you name a few? Well, I mean, are you doing this as like a formal company? Are you doing this as a company, or are you doing this as like a student project? So I change HTTPS to show it. Show it? What are we showing? Oh, you're doing an internship. Okay. I mean, if you want to do some, if you want to do some like pointed security testing tool in it, I'd suggest doing something like Burp Suite. So the dynamic application scanner. The thing is this. The thing is that this is not. It's not free. If you want to like do some agentic LLM stuff, you might want to. You could try that as well. The thing is that that's also not free, but it's probably going to be a lot less expensive than pointing like a professional product at it, like Portswigger. Sorry, Burp Suite. Burp Suite on its automated scanner. So you could probably give over your application code over to your LLM to try to identify potential problems with that. So for example, you could do, wow, I don't know, like ChatGPT, chatgpt.com, or you could do like Google Gemini. What you'd do is you would paste in the code into the LLM and try to have it identify potential security flaws. So in here, in Gemini, you would say, please ID any potential security issues with this website code. And then you would paste in code here. Okay, and then it would probably, well, it would tell you whether or not there are any issues with the code. It's a lot cheaper than using like a professional product. Of course, it's probably not going to catch as much as a professional product. Okay, so for this problem here, let's just think about this. Okay, so we're asking program that prints out a number of, what was it? Asterisk hash symbol characters. The output will look kind of like half of a pyramid. We need 2 loops. The first loop will keep track of the number of reps to print. The second loop will keep track of, so we keep track of the number of repetitions of this character to print out. The second loop will keep track of when to stop stop the operations in general, right? Moodle ones can also be done? Yeah, I mean, all you need to do is copy the Moodle code. So the code of the web pages, and that's, I mean, inside of Moodle, you can just copy off the contents of the pages and then feed it into the LLM and ask it if it's got any recommendations for security stuff. So for example, it might be able to identify like if sensitive information is exposed in the code, or if the file upload, if the locations that are being accessed. One thing that you really want to keep track of when you're using AWS is whether or not your AWS implementation is safe. For example, if you're using AWS keys correctly, or if you're implementing your buckets correctly, that kind of thing. Where can I look for your Moodle content? I mean, the Moodle content that I was doing was not very complex. It was just basically hacking a insecure Moodle app. So you can look. When was that stream? It was last week. So probably over here. Yeah, the university box. So just take a look at the VOD for July 8th, and take a look at the last topic from that stream. You will be able to see it. So we were covering a Volnix box, so basically like a hacking scenario where we dealt with the Moodle web app. Okay, the first loop will keep track of the numbers of reps to print. The second loop will keep track of when to stop stop operations overall. Okay, so the first loop. Repetitions is set to 0, and then we can do while repetitions is not equal to, so it has to do 1 and then 2 and then 3. 1 and then 2 and then 3. While repetitions is not equal to counter, because we're taking in the input as the counter, right? While repetitions is not equal to the counter, print asterisk this thing, and then increment repetitions up by 1. Then again, we also need like another counter, right? Because each layer is going to be one set. So layer 1 equals a set. Layer 2 equals two sets. Layer 3 equals 3 sets, etc., etc. Now, how do we know when to stop this? Because we need to print off 1. Then when it's equal to I mean, this is another counter we need to keep track of, right? So we do like set equals 1. And then after the set is finished, we increment the set by 1. Set equals 1. Cypher, hello, nice to see you here. Print the stuff. If repetition equals set, so set equals 1, if the number of repetitions equals the set, then break out of the loop. Why is it so hard to me to imagine this code? Print a thing. Let's just pretend that we're just dealing with 2, right? So user input equals 2. Cypher says, how are Facebook accounts hacked so easily when genuine people keep getting locked out of for failing integrity? I haven't heard very much about people's Facebook accounts getting hacked lately. Let me know what's going on with that, Cypher. So if user puts in 2, then we'll do the number of layers. We need 2 layers. Layers will start at 0. So I guess we could call the user input like the target. So while layers is not equal to target. Password reuse in leaked databases. I thought, what is the word? Facebook accounts require like 2-factor authentication. Is 2-factor authentication not mandatory for Facebook accounts? Two-factor authentication is not universally required for all personal Facebook accounts to log in. It is highly recommended and sometimes automatically enforced if Facebook detects unusual login. Okay. So Nullsec says it isn't mandatory and old accounts don't necessarily have it. So I mean, I guess it's possible if people haven't implemented 2FA. I mean, the thing is that Facebook became popular before 2FA became like a standard thing for login. Cypher says, let's say they take your face. It's not as simple as a guess a password anymore. Some old people don't have smartphones. 2FA would be hard for them. Most common request, can you hack Facebook? Oh, really? I haven't been keeping up with Facebook too much. So while layers is not equal to the target, then so this is where the second do while loop goes in. So when the number of layers is equal to the target, we end the first while loop here. But the second while loop is while well, repetitions is not equal to the target, and we would initialize repetitions equals 1. And inside of this loop, okay, I keep seeing accounts getting taken over by spammers. Okay, most common complaint for me is I got banned from my own account trying to guess a forgotten password. Oh, are you talking about like lockout? I was on 2007, success sent to C99 PHP shell on Facebook comment. C99 PHP shell? Oh, 2007, okay. This was back in the Wild West. I mean, 2007 is only 2 years into, like, Facebook's history, right? I'm pretty sure that it came out in, like, 2000... Was it 2005 or 2004? So repetition equals 1, and then print the thing. Print the thing. But what happens after we print the thing? Nedmax says, I'm still here. I won't be able to sleep until this is solved. Oh, I'm actually I'm not very confident I'm going to be able to solve this anytime soon. I don't think... I'm not sure if I'm going to be able to solve this in the next 10 minutes or so, unfortunately. Okay. How do you find folks feel about federated networks? So, NG Carson, hello, nice to see you here. Federated networks. We're talking about, like, are we talking about the Fediverse? So stuff like, Mastodon? So decentralized. Fediverse, Mastodon, let's see. Explore federated networks. So is this what you're talking about? The Fediverse? Yes, and projects that come after. Yeah, I mean, I've heard a lot about decentralized stuff. The unfortunate thing is that, like, these Fediverse apps, they're not super popular. I wish they were, because it would be fun to be able to post to new, like, more locations, like the Fediverse version of YouTube, for example. The Fediverse version of YouTube is PeerTube, and it would be fun to be able to upload to PeerTube. Unfortunately, nobody would watch my stuff if I uploaded it to PeerTube, except other people. I mean, it's hard to advertise to the people on PeerTube. But I mean, the concept is really nice. You don't want all of your stuff to be owned by the big companies like Google and Meta and all those big scary companies. Feels like a way to win the FOSS battle, paying celebrities to endorse projects. Henky says, gotta go, see you on the next stream. See you next stream, Henky Lodwig. Print the string. So it has to go 1, then 2, then 3. 1, then 2, then 3. I mean, this is the thing, right? We need something that keeps track of the first layer. So the first layer is 1, the second layer is 2, the third layer is 3. how do we implement this check? How do we know when to make a new line? So this has to be some other iterator. What are we making? Red. Hi, how are you doing? We're currently doing this problem. And I'm not sure if you're probably not going to be able to see it unless you're logged into the website. NG Carson, thank you very much for subscribing on YouTube. Much appreciated. Okay, we've got a little ad break happening on Twitch. I haven't taken a water break this entire stream. Hold on. I'm just gonna have a little bit of water, but in the meantime, check out these birds. I'll be back in about 60 seconds. I just need to have a little bit of water. Okay, thank you, NedMac. Yeah, these are my backyard birds. I've got a little camera that that records the bird bath here, and sometimes like the bird feeder, and it's fun to watch the birds having a lot of fun. Anyways, we'll put the birds away. We'll get back to the programming stuff. Okay, let me see if we can get some hints here. Write a program that asks the user to enter a number. Then, the program should print the number of lines corresponding to the number inputted. Print the number of lines corresponding to the number inputted. Okay. Each line should contain a number of pairs of the characters this equal to the number of this line. So, I mean, the outputted drawing should be similar to the right half of a pyramid. Okay, so it suggests that you should use 2 do-while loops. Birds are fun to watch. Yeah, birds are the closest thing to dinosaurs that we'll ever see in our lifetimes. So it's they're very fun little things to watch. How do we know when to make a new line? So if we initialize like current reps equals 1. When print the string so when we break out of this loop, have you ever seen the dinosaurs depicted with feathers? Yeah, they look fabulous, right? Dinosaurs with feathers. So these things right here. They look a lot less terrifying, I guess you could say. Anyways. User will input a character. Did you manage to get the correct decimal from it? User will input a character. I mean, the thing is that for this particular exercise, the user inputs a number. So that's the number of layers of the pyramid. So for example, like if the user input is equal to 3, then there should be 3 layers of this pyramid thing. So this thing, and then print off. Oops. Darn it. So if the user inputs the number 3, then it should print 3 layers of stuff like this. So the first layer, if the user input is 1, then it only prints off that. But it prints off a subsequent number of these things depending on how much user input is in here. Ignifer says, dinosaurs with feathers look like they'd be good with barbecue sauce. Yeah, that's true. The real reason they went extinct is because they tasted too good with barbecue sauce? Maybe. Okay, so let's just think about this for another 15 minutes or so, and then I really gotta go. Okay, could you do lessons on English for cybersecurity? English for cybersecurity? Okay, what do you think of the new PicoCTF site? You're talking about, like, what was it called? Scilab? So PicoCTF is not PicoCTF anymore, it's called scilabacademy.org. And it seems to be better. It seems to be better than the previous PicoCTF. Red says, in 51 decimal ASCII value? Oh, okay. I mean, El Mexican, hello, nice to see you here. What's up? We're just trying to puzzle over how to solve a little programming problem. Are we doing a hacker stream this week? Yeah, we're going to be doing 2 hacker streams this week. It's just that I'm trying to experiment with a new format for live streams. So Tuesday will be co-working. Then Wednesday is going to be Hacking Stream 1, and Friday is Hacking Stream 2. I actually wanted to add one more day as well, like Sunday, so we can do something that is exclusive to coding stuff. So I mean, we're doing coding today, but like co-working isn't always going to be coding for me. I might be learning other topics, like we could do co-working. I mean, I'm thinking I could do coding, I could do like cryptography, because there's lots of cryptography stuff that I need to study as well. But we might do like one special day for coding and one for co-working, and these will be short streams, like 3 hours, done at like West Coast late night hours. But Wednesday and Friday are going to be the regular old ones. Glutton for punishment. Yeah, I mean, I guess I am. Short. I should limit myself. So like coding something like LeetCode, and I would be doing this in Python, which is my preferred language, as opposed to learning new coding stuff in like C. Okay, so if the user inputs 3, then it has to print 3 layers of this string over here. So the first one is we check target. We'll have like a variable called target reps. So target reps equals 1, and then when we hit the target reps, then target reps increases by 1, and then the target reps increases by 1 again after we match that one. I feel the same when it comes to Python. I found it easier to understand when compared to C. What is the timer? 11 minutes. So we're going to be, well, that's the end of the stream. We're only going to be streaming for the next 11 minutes or so. Brain equals cooked. My brain is a bit cooked. You need to do something obscure like Zig or COBOL. Sunday in US and Canada. Sunday in US and Canada? Yeah. Sunday in US and Canada, not... Well, I mean, I'm not too sure where everybody else is. So the first one will keep track of, like, layers. So the user input equals 3. The user input becomes the layers. When layers equals user input, the loop exits. Dethel Stench? Dethel Stench, that's a name? That sure is a name. Thank you very much for subscribing on YouTube, thank you. When the layers equals to the user input, then the loop exits. So I guess we initialize layers at like 0, right? When the layers equals the user input, the loop exits. Okay, and then inside of layers, we also need to keep track of the repetitions. Deathly? Why do you start the stream so early in the morning? Brembo, you must be in Europe, Brembo. 'Cause it's morning in Europe right now, right? Okay, so I guess the user input is also going to be 3. So target reps equals 1. So start at 1, and it's while target reps is not equal to user input plus 1. Target reps equals 1. Print the string target reps plus plus. So do the thing, print it once, print the string, when target reps, no. Actually, there's target reps and then there's current reps. The current repetitions, it is initialized to 0. Okay, what time is it there right now? Nullsec says 2300. 2300, yes. 2300 for West Coast, where I am right now. Nullsec, you must be in the same in the same time zone. Ganesh Ravadran, thank you very much for following on Twitch. Thank you. Oh no, you're at 2 a.m. for you. Okay, 2 a.m. Oh, alright, you must be on the West Coast. For me, it's 9 a.m. 9 a.m.? Where is it 9 a.m.? And, Ganeshra Vidran. Hello, nice to see you here. Okay, let me do a quick search. Where is it 9 a.m. right now? Eastern Europe, okay. Turkey and Bulgaria, from Bulgaria. Oh, interesting. Learning COBOL would be awesome, but I'm loving this C stuff. I'm I'm trying to get a handle on this. Okay, we got 5 minutes. So the current repetitions is 0. Print the string. You know what? I think it might be easier for me to imagine this in Python. Hold on. Okay, so let's write a little Python script. So we'll write the Python script here, and we'll run it from this window right here. Okay, so the input function target equals input input a number. Then we would do something like for. If you want to guide someone from scratch about coding and cybersecurity, what would be your advice? Okay, so TBA guy, hello, nice to see you here. I've got something that talks about like getting into cyber from scratch. Get into cyber. So this, get into cyber. This link right here. So if you click on that, it'll lead you to a post on my Reddit, and it talks about how to start from scratch. How to start from scratch doing cybersecurity and technical topics. If you want to learn about like coding in particular, I've got a bunch of education resources over on my GitHub for different programming languages. So try this. NedMac says, have a good night. Best of luck. Thank you very much, NedMac. And hope to see you again sometime. And have a good night. But yeah, I've got a bunch of programming resources for learning like stuff like Python and C, JavaScript. Go ahead and try one of those courses. I need to go to bed too? No worries, no worries. Have a good one, guys. We're going to be finishing up in just a bit anyways. Okay, so for... Is it while true? Do some stuff. Print this thing. It was like that. Print that, then I guess we need to initialize the other variables here. So the target is this thing. Target reps is initialized to 1. Current reps, so this is for keeping track of the printed strings. Okay, Shooter McGav, hey, I haven't seen you in a while. What is up? I see Pico CTF changed donors. are the labs from your videos still on the new site? Well, I mean, it didn't really change owners. PicoCTF was always owned by Scilab. So Scilab over here. So PicoCTF was always part of Scilab. So Scilab was the larger organization. It's just that PicoCTF has been like absorbed into the larger organization, which is Scilab. And Scilab has taken over basically for branding of PicoCTF. Thank you very much, Nestor Daniel, for following on Twitch. Thank you. Thank you very much. Okay, so the target repetitions is 1, and the current repetitions is going to be 0. So while true, print this thing. And then current rep plus equals 1. So increase current repetitions and do the check. If crep is equal to trep, then trep increases. Trep goes up by 1. Oh man, I have no idea what we're actually supposed to be doing here. Okay, so we gotta go because it's getting late over here. I guess the reason why I'm not doing as well is because it's also quite late. But let's talk about some people we could pass you over to over on twitch.com. Sorry, twitch.tv. Just a second. Okay, so it looks like Science Streams is on. Let's take a look at what they're doing. So there are people who do science content over on Twitch. They're always talking about microscopy and biology stuff. Lots of fun. What do you think about Claude, an agent that tests software and bug bounty tasks with the goal of making money? I mean, if you're talking about using an AI agent to make money from bug bounty, I don't know if... Oh, they're offline. Are they offline? I saw they were online. Hold on. Let's put that in one more time. Oh, they are offline. Okay, let's see if we can find somebody else. Maybe I can pass you guys over to the Dark Side Diaries. So the Dark Side Diaries channel is always okay. Oh, you're going to be going to college soon. Awesome, awesome. So be sure to check out the Get Into Cyber thread over here. So what are we talking about? Okay, so this stuff is always pretty random. So right now, the channel basically runs through a bunch of like technical hacker talks. So stuff from DEF CON, from Black Hat, and other conferences. And it's always a lot of fun. So let's raid into their channel. Dark Side Diaries. Okay, so before we go, let's talk about what we're going to be doing. We're going to be doing another stream tomorrow. So it's going to be on Wednesday, July 15th from 2 p.m. to 8 p.m. PST. We're going to be doing some puzzle gaming. We're going to be doing a demo of a try-hacking module called Basic Pen Testing. We're going to be taking a look at file upload attacks over at HackerFrogs After School. And then we're going to be doing a Linux CTF box we've never seen before called Dark over at Hack Smarter. So please come back tomorrow and we'll have more hacking fun. Okay, one woman hacked my heart. Protect my life. One woman hacked your heart. I don't know if we can protect you against that. All right, everybody. We'll be back tomorrow. Hope to see you then, and have a great day. HackerFrogs out in 5, 4, 3, 2, 1. See you next time.